Hello, welcome back.
Welcome back. I'm John, an old YouTuber, and next year I will be even older.
It's summer in Denmark, the weather is super nice.
But I'm still low on money. I will be that next month and rest of the year and most part of next year. So I cannot do anything, just pay my bills and buy some cheap food. Then we can do something else later next year maybe. And I still try to lose some weight. Gonna eat big bag of candy last night, 300 gram, and French fries. But I'm ready for the next one. So, and I cannot read 1,000 pages without it takes a lot of time. It will take many days and many weeks. I don't know how long time it take. Probably it take a long time to read all this. But I like to do it. But why I should not do it? If I like to read about it, if I should not do this, what should I do? I could watch Netflix. I cannot play. This computer is not strong enough to play modern computer game. This is 8th generation. I cannot play computer game anyway, and I'm not going to watch Netflix my whole day, and I'm not going to walk around on the streets outside the whole day. Nowhere to go and have no money. I don't know why I should do that, so I just stay at home for now. Well, this is gas engine. I don't know much about gas engines, but I could learn a bit if I read this. So why not do this? If I like to do it now, I never tried this. Yes, I did start to do this last month, but I never tried to do this. Many weeks. Yes, let's try again. Read loud, read to end of documents.
Gas engine. Gas engine for electric power generation model of an S-type hardtop gas engine. A gas engine is an internal combustion engine that runs on a gaseous fuel, such as coal gas, producer gas, biogas, landfill gas or natural gas. In the United Kingdom, the term is unambiguous. In the United States, due to the widespread use of gas as an abbreviation for gasoline, petrol, such an engine might also be called a gaseous-fueled engine or natural gas engine or spark-ignited. Generally in modern usage, the term gas engine refers to a heavy-duty industrial engine capable of running continuously at full load for periods approaching a high fraction of 8,760 hours per year, unlike a gasoline automobile engine, which is lightweight, high-revving and typically runs for no more than 4,000 hours in its entire life. Typical power ranges from 10 kilowatts, 13 HP, to 4 MW, 5,364 HP. 1. Contents. History. Lanoi. Otto and Langen. 4-stroke engine. Crossley. Tangai. Preservation. Current manufacturers. Typical applications: stationary. Transport. Use of gaseous methane or propane. Technical details: fuel-air mixing. Exhaust valves. Ignition. Energy balance: thermal efficiency. Combined heat and power. Engine cooling. Gas consumption formula. Gallery of historic gas engines. See also. References. External links. History. Lanoi gas engine 1860. Otto Langen gas engine 1867. Lanoi. There were many experiments with gas engines in the 19th century, but the first practical gas-fueled internal combustion engine was built by the Belgian engineer Etienne Lannoy in 1860. However, the Lannoy engine suffered from a low power output and high fuel consumption. Otto and Langen. Lannoy's work was further researched and improved by a German engineer Nicolaus August Otto, who was later to invent the first four-stroke engine to efficiently burn fuel directly in a piston chamber. In August 1864 Otto met Eugen Langen, who, being technically trained, glimpsed the potential of Otto's development, and 1 month after the meeting, founded the first engine factory in the world, now Otto and C in Cologne. In 1867 Otto patented his improved design, and it was awarded the grand prize at the 1867 Paris World Exhibition. Thies atmospheric engine worked by drawing a mixture of gas and air into a vertical cylinder. When the piston has risen about 8 inches, the gas and air mixture is ignited by a small pilot flame burning outside, which forces the piston, which is connected to a toothed rack, upwards, creating a partial vacuum beneath it. No work is done on the upward stroke. The work is done when the piston and toothed rack descend under the effects of atmospheric pressure and their own weight, turning the main shaft and fly wheels as they fall. Its advantage over the existing steam engine was its ability to be started and stopped on demand, making it ideal for intermittent work such as barge loading or unloading. 3. Four-stroke engine. The atmospheric gas engine was in turn replaced by Otto's four-stroke engine. The changeover to four-stroke engines was remarkably rapid, with the last atmospheric engines being made in 1877. Liquid fuel engines soon followed using diesel, around 1898, or gasoline, around 1900. Crossley. The best-known builder of gas engines in the United Kingdom was Crossley of Manchester, who in 1869 acquired the United Kingdom and world, except German, rights to the patents of Otto and Langdon for the new gas-fueled atmospheric engine. In 1876 they acquired the rights to the more efficient Otto four-stroke 3 bhp gas-fired Crossley atmospheric engine in action at Anson Engine Museum. Cycle engine. Tangway. There were several other firms based in the Manchester area as well. Tangway Limited, of Smethwick, near Birmingham, sold its first gas engine, a 1 nominal horsepower 2-cycle type, in 1881, and in 1890 the firm commenced manufacture of the 4-cycle gas engine. 4. Preservation. The Anson Engine Museum in Point On, near Stockport, England, has a collection of engines that includes several working gas engines, including the largest running Crossley atmospheric engine ever made. Current manufacturers. Manufacturers of gas engines include Hyundai Heavy Industries, Rolls-Royce with the Bergen engines, Kawasaki Heavy Industries, Liebherr, MTU Friedrichshafen, GE Jenbacher, Caterpillar Incorporated, Perkins Engines, MWM, Cummins, Wärtsilä, GE Energy Walksha, Glasgow Power, Deutz, MTU, MAN Fairbanks Smorse, Doosan, and Yanmar. Output ranges from about 10 kilowatts, 13 HP, micro combined heat and power, CHP, to 18 MW, 24,000 HP. 5. Generally speaking, the modern high-speed gas engine is very competitive with gas turbines up to about 50 MW, 67,000 HP, depending on circumstances, and the pistons are much more fuel efficient than the gas turbines. Rolls-Royce with the Bergen engines, Caterpillar and many other manufacturers base their products on a diesel engine block and crankshaft. GE Jenbacher and Walksha are the only two companies whose engines are designed and dedicated to gas alone. Typical applications. Stationary. Typical applications are baseload or high-hour generation schemes, including combined heat and power. For typical performance figures see 6, landfill gas, mines gas, wellhead gas and biogas, where the waste heat from the engine may be used to warm the digesters. For typical biogas engine installation parameter C.7, for parameters of a large gas engine CHP system, as fitted in a factory, C.8. Gas engines are rarest for standby applications, which remain largely the province of diesel engines. One exception to this is small, and LT 150 kW, emergency generator often installed by farms, museums, small businesses, and residences. Connected to either natural gas from the public utility or propane from on-site storage tanks, these generators can be arranged for automatic starting upon power failure. Transport. Liquefied natural gas, LNG, engines are expanding into the marine market, as the lean burn gas engine can meet the new emission requirements without any extra fuel treatment or exhaust cleaning systems. USUF engines running on compressed natural gas, CNG, is also growing in the bus sector. Users in the United Kingdom include Reading buses. Use of gas buses is supported by the Gas Bus Alliance, 9, and manufacturers include Scania AB. 10. Use of gaseous methane or propane. Since natural gas, chiefly methane, has long been a clean, economical, and readily available fuel, many industrial engines are either designed or modified to use gas, as distinguished from gasoline. Their operation produces less complex hydrocarbon pollution, and the engines have fewer internal problems. One example is the liquefied petroleum gas, chiefly propane. Engine used in vast numbers of forklift trucks. Common United States usage of gas to mean gasoline requires the explicit identification of a natural gas engine. There is also such a thing as natural gasoline, 11, but this term, which refers to a subset of natural gas liquids, is very rarely observed outside the refining industry. Technical details. Fuel air mixing. A gas engine differs from a petrol engine in the way the fuel and air are mixed. A petrol engine uses a carburetor or fuel injection, but a gas engine often uses a simple Venturi system to introduce gas into the airflow. Early gas engines used a 3-valve system, with separate inlet valves for air and gas. Exhaust valves. The weak point of a gas engine compared to a diesel engine is the exhaust valves, since the gas engine exhaust gases are much hotter for a given output, and this limits the power output. Thus, a diesel engine from a given manufacturer will usually have a higher maximum output than the same engine block size in the gas engine version. The diesel engine will generally have 3 different ratings: standby, prime, and continuous, aka 1-hour rating, 12-hour rating and continuous rating in the United Kingdom, whereas the gas engine will generally only have a continuous rating, which will be less than the diesel continuous rating. Ignition. Various ignition systems have been used, including hot tube igniters and spark ignition. Most modern gas engines are essentially dual-fuel engines. The main source of energy is the gas-air mixture, but it is ignited by the injection of a small volume of diesel fuel. Energy balance. Thermal efficiency. Gas engines that run on natural gas typically have a thermal efficiency between 35 to 45%, LHV basis. 12. As of year 2018, the best engines can achieve a thermal efficiency up to 50%, LHV basis. 13. These gas engines are usually medium-speed engines. Sturgeon engines. Fuel energy arises at the output shaft. The remainder appears as waste heat. 8. Large engines are more efficient than small engines. Gas engines running on biogas typically have a slightly lower efficiency, 1-2%, and Syngas reduces the efficiency further still. GE Jenbacher's recent J624 engine is the world's first high-efficiency methane-fueled 24-cylinder gas engine. 14. When considering engine efficiency, one should consider whether this is based on the lower heating value, LHV, or higher heating value, HHV, of the gas. Engine manufacturers will typically quote efficiency as based on the lower heating value of the gas, i.e. the efficiency after energy has been taken to evaporate the intrinsic moisture within the gas itself. Gas distribution networks will typically charge based upon the higher heating value of the gas, i.e., total energy content. A quoted engine efficiency based on LHV might say 44%, whereas the same engine might have an efficiency of 39.6% based on HHV on natural gas. It is also important to ensure that efficiency comparisons are on a like-for-like basis. For example, some manufacturers have mechanically driven pumps whereas others use electrically driven pumps to drive engine cooling water, and the electrical usage can sometimes be ignored, giving a falsely high apparent efficiency compared to the direct drive engines. Combined heat and power. Engine reject heat can be used for building heating or heating a process. In an engine, roughly half fewest heat arises from the engine jacket, oil cooler and aftercooler circuits, as hot water, which can be at up to 110 degrees Celsius. The remainder arises as high temperature heat, which can generate pressurized hot water or combined heat and power. 1905
Yes,
National Company's
I had to
Audenrigus
stop.
engine of 36 HP.
I did click by mistake. I did that when I start to get sleepy. I think I will have to read page by page.
When considering engine efficiency, one should consider whether this is based on the lower heating value, LHV, or higher heating value, HHV, of the gas. Engine manufacturers will typically quote efficiency as based on the lower heating value of the gas, i.e. the efficiency after energy has been taken to evaporate the intrinsic moisture within the gas itself. Gas distribution networks will typically charge based upon the higher heating value of the gas, i.e., total energy content. A quoted engine efficiency based on LHV might say 44%, whereas the same engine might have an efficiency of 39.6% based on HHV on natural gas. It is also important to ensure that efficiency comparisons are on a like-for-like basis. For example, some manufacturers have mechanically driven pumps whereas others use electrically driven pumps to drive engine cooling water, and the electrical usage can sometimes be ignored, giving a falsely high apparent efficiency compared to the direct drive engines. Combined heat and power. Engine reject heat can be used for building heating or heating a process. In an engine, roughly half fewest heat arises from the engine jacket, oil cooler and aftercooler circuits, as hot water, which can be at up to 110 degrees Celsius. The remainder arises as high temperature heat, which can generate pressurized hot water or steam by the use of an exhaust gas heat exchanger. Engine cooling. Two most common engine types are an air-cooled engine or water-cooled engine. Water-cooled nowadays use antifreeze in the internal combustion engine. Some engines, air or water, have an added oil cooler. Cooling is required to remove excessive heat, as overheating can cause engine failure, usually from wear, cracking or warping. Gas consumption formula. The formula shows the gas flow requirement of a gas engine in norm conditions at full load. Where is the gas flow in norm conditions? Is the engine power? Is the mechanical efficiency? LHV is the low heating value of the gas. Gallery of historic gas engines. Historic gas engines.
Yes, we have to read page by page.
1905 National Company's Audenrigus engine of 36 HP. 1903 Korting gas engine. Bacchus upright gas engine. Otto horizontal gas engine. Otto vertical gas engine. Westinghouse gas engine. Crossley gas engine and dynamo. Premier twin gas engine electric generating plant.